last day we started talking about day 2, and we're starting to look at different rules about exponents. And we looked at, hey, what happens when you have 2 powers and you want to multiply them? And we had a rule, and the rule went like this. As long as the bases were the same, all you had to do is add the exponent together. 7 and 2 makes 9. Right? Basically all it means is this 7 here means that we have 7 of these 3's here, and this 3 here, we have 2 of them there. Altogether we had 9. Right? It was pretty straightforward. There was one tricky situation. That tricky situation occurred when a base didn't have an exponent. In that case, there was an imaginary 1. It didn't mean there was a 0. It meant there was an imaginary 1 there. So in this case, there's 2 6's here, 1 6 here. Altogether, there are 3 6's. Right? That's all that meant. Okay? So multiplying, you add the exponents. And if the bases are different, and that means we can't combine them, we just write down not possible. So now today we're going to look at the other situation. Is what do we do when we are dividing? Right? So let's go over here. So the rule for dividing, once again, only works if the bases are the same. Right? And before we go over the rule for what dividing is, we're going to show you how it works because it makes more logical sense. Now, I think for most students, the explanation for this will work better if we look at this as a fraction instead of a division statement. Because a fraction and a division statement means the same thing, all right? So when we're dividing, we have 2 numbers, a number on the top and a number on the bottom. So I have my fraction line here. Of the 2 numbers, let's go for blue and purple. Which 3 goes on the top of the fraction? Is it the blue 3 or the purple 3? Sorry? Blue. The blue. The first one is the numerator. So the first one goes on the top. So I'm going to rewrite this division statement as a fraction. So I'm going to go 3 7 here and 3 squared here. Okay? And so what does this equal? Well, on the top, it means we have 7 3's. That's what the power as a repeated multiplication looks like. So I'm going to draw out 7 3's. A bigger explanation. 1, 2, 3, 4, 5, 6, 7. All right. And on the bottom, we got 2 3's. Okay. So now we want to clean this up because we don't want to write this as a repeated multiplication. And to some of you guys, cleaning this up will be really easy depending on how your grade 8 teacher taught you fractions. So for my class is grade 8, we sort of talk about this already. So if you have a number on the top and the exact same number shows on the bottom, they can cancel each other out. I'm hoping your grade 8 teacher talked to you about that. I went around and talked to some of the grade 8 teachers last year and said, hey, can you please teach your kids this when you're cleaning up fractions? Makes grade 9 a little bit easier. So a 3 on the top, when you're multiplying, can cancel a 3 on the bottom. And if you haven't seen this before, the only reason this works is because if we have a 3 over 3 like this, 3 divided by 3 is 1. So they kind of disappear and they cancel each other out. Okay? So 3 divided by 3 is 1. So 1 3 in the top can cancel 1 3 in the bottom. Then we can grab another 3. Go here. Escape. Oh, come on. This 3. Oh, come on. This 3 can cancel this 3. All right, so it's a top bottom. Who's seen that before? Can I show a hand? Only about a quarter of you guys. Okay. All right, so now this 3 cancels this 3 because it makes 1. It doesn't make 0. It makes 1. That's why it disappears. And 1 times anything, it still stays the same. So what we have left over is this bunch of 3's. So if I wanted to write those bunch of 3's as a power, would be 3 to what exponent? Liam?
5.
Thank you. 5. Okay? So now, if we want to figure out the shortcut, so you can be lazy and not write out all these multiplications, what's the Leah, what's the rule? Yeah. So all we had to do is go 7 minus 2 gives us 5. So the rule is when you're dividing, you subtract the exponents. Okay? Multiplying we add, dividing we subtract. Which sort of makes sense. They're kind of multiplying and dividing are opposites of each other. So the rules should be opposites of each other. Alright? So one more thing to memorize. And if you don't memorize it, the good thing is you can always draw it out with all the multiplications here and just do the canceling and figure out the rule that way. It's more work, but if you need to remind yourself, that is fine. Okay? Alright, so let's do some practice here. So the first one. Are the bases the same? Yes. Right, so the base stays the same. We combine the exponents. What should the exponent be? Liam?
3 to the power of 2.
Yes, thank you. The next one, right? The bases are the same. So when you're writing it down, make sure you include the brackets because the bracket is a part of the base. So -3, like that. What should the exponent this time be? Liam again.
Bracket -3, close bracket 3.
Yeah, like that. So 10 minus 7 gives us the 3. All right. Next one. Our bases are the same. So if we write down the base, what should our exponent be? Liam?
It should be 1 because 3 minus each other.
Do you guys agree with Liam on that one? What's 2 minus 2?
0.
0. So it shouldn't be 1. Now, remember from last day that we can't leave it a blank. A blank doesn't mean 0. Right? Remember, a blank means 1. So we actually do need to put that 0 in. Okay? So now if we calculated these, that's what evaluate means. Right? The first one, 3 to the exponent 2. Is that 6? No. 9. That's the common mistake. It means 3 times 3, not 3 times 2. Next one. The answer is 27. But is it positive 27 or negative 27?
Negative.
Negative, because you have that negative sign repeating 3 times. Negative 27. Next one. Try it on your calculator. What does it give you?
0.
It doesn't give you 0. I heard somebody say it over here. Misha? 1. And we're going to learn this. This is a property of exponents. Anything to the exponent 0 is always 1. And that's coming up in maybe next day's lessons or the day after that. And the reason why, it's kind of like, well, what's going on here? It's because if you let's go back to the fraction and to the division statement here. We have 8 squared over 8 squared. So if we calculated that out, instead of doing the simplifying with the powers, on the top is 8 times 8, which is 64. On the bottom we have 8 times 8, which is 64. And what are we doing? 64 divided by 64, which is 1. Right? So we'll talk more about that coming up in a future lesson. All right, so now onto the back page. I think I'm going to skip this question, but I can give you a different question instead. All right, so on the right-hand side, I'd like for you to please write a more complicated example than what we've been doing. So we're going to start looking at the situation of what happens when you have multiple things going on here. All right, over like this. please write that one out. Skip the one on the left and just do this one instead. All right. So the goal is to write this as a single power. Right? So everything sixes, we want 6 with 1 exponent. Now we have multiplying and dividing going on here. Right? And so we're going to come across these kind of situations a lot in coming lessons. Right? We have lots of things going on in the numerator. My tip for you guys, before we clean up and down like this, make sure the top is a single term and the bottom is a single term. So clean up the top and clean up the bottom. So here, if we looked at just the top, say in orange here, and we wanted to clean this up, ignore the bottom altogether. Imagine that was your only question. Are the bases the same?
Yes.
Yes. So now this is a little bit different than the questions we did in the first page because there's more than one power. But do you think that changes the rule?
No.
No, right? So when we're multiplying, the rule is we add the exponents. So we go 3 plus 5 plus 2. What number do we get there? 10. So 6 to the exponent, 10. Then we do the same thing at the bottom. We ignore the top and we clean the bottom up to a single power. Right? So the bases are 6. What should the exponent be? 5. Remember that this one doesn't have an exponent, so it has an imaginary 1 there. So 6 with a 5. Okay? So now that the top is a single power and the bottom is a single power, we can clean up this way. So our fraction line just means divide. Nick?
It's 6, 5.
Exponent 5. 10 minus 5 is 5. Okay? Okay, one more. What if I took just the top one and I rewrite it into a slightly different question? So I'm going to do a new question here. What if I went 6, 3 times 6, 5 divided by 6, 2? So we have a mixture of multiplying and dividing all at once. Right? Okay. Any guesses how we would tackle this problem? Ashelia? Oh, yeah, so remember the division separates the numerator and the denominator. So if we wrote this as a fraction, it'd go like this. 6 squared. And on the top, 6 cubed times 6, 5. All right? And this makes it a lot nicer to look at. All right? So if we do what we did last time, we clean up the top. What do we have on the top?
6 to the power of 8.
8. Right? 6 with an 8. 3 plus 5 is 8. What do we write down on the bottom?
This stays the same.
Stays the same. It has nothing to combine with, so it stays the same. All right? Then all we do is clean this up. All right? 8 and 2, Ashelia. 6 to the 6, like this. Right? Now, eventually, it takes more effort to write it out as a fraction, but I think it makes it a lot clearer to see. But you will get good at it. You're like, hey, you could have done it straight from this line. Multiplying, I know I add. Dividing, I subtract. So you could have done 3 plus 5 is 8. 8 minus 2 is 6. But you'll get there, right? Some of you guys may already be there right now. You can probably just look at the first, top one and get it. But that's it. So we're learning all these different rules they call power rules.